I was briefly discussing how plants will make molecules to affect other organisms. In the case of caffeine attracting the flowers will attract insects, and the caffeine in the ground will deter growth of other organisms. Before you joined Dr. Timothy, we also discussed how CBD is a chemical that prevents under foliage growth that the cannabis plant makes. I do a lot of talks on that. And we also just talked about chemicals like nicotine affecting nervous system. And now I want to just kind of segue into chemical communication from plants. For example, if aphids are overfeeding on some plants, they will release an aromatic terpene. Farnesene is the terpene that mimics the aphid alarm pheromone. So it mimics an insect danger signal that warns the insects of approaching predators. So it basically is, in this particular instance, the plant is making a chemical to specifically fool the aphids into thinking that there is a danger in the environment. And what's really cool is that for example, lots of plants do this. Spider mites and lima beans, when the spider mites hit the lima beans will release volatile terpenes that, instead of driving away the spider mites, these terpenes actually attract other predatory insects that then feed on the spider mites. So the plants can tell exactly what type of mite is feeding on them because they can analyze the chemistries of their saliva. And then each plant species will then produce a different blend of volatile oils, usually terpenes, depending on what kind of spider mite is feeding on it. So the plants are actually doing some really cool and intelligent things. And the plants will also mix only the particular chemicals that feed on that type of a mite. So the plants, and then the plants can also tell other uninfested lima beans in the surrounding area that, hey, we've got a problem here. And then when those plants receive the communication, they also begin to release those very specific chemicals. So, and there's lots of examples of this. I don't want to be too far from my mic because I don't want that to be a problem. So just raise your hand if you can't hear me. So a lot of the times the plants are detecting the saliva of the insect. So if there's a particular caterpillar that the plant in a different plant, the plant senses that this caterpillar is eating on it, and then the plant will actually call in wasps. And so this communication process is remarkably sophisticated. And I find it fascinating that many of the plants, specifically cannabinoids and terpenes, which are a little bit more in my wheelhouse, are very specifically targeted chemically. And if in the case of the caterpillars, if the feeding goes on for more than 2 hours, the whole plant starts to emit the compounds, not just in the local area. So there's an efficiency process that's happening here. The plant is being efficient when the caterpillar attacks. It analyzes the saliva. It knows exactly what type of caterpillar is coming, and then it initiates a localized response to produce chemicals. And then after 2 hours, it becomes generalized throughout the whole plant. And then depending on the species, it can alert other plants in the surrounding area. So we see this all over the plant kingdom. And why I talk about it is because I think a lot of us don't really get an education on why and how specific plants are about making these chemicals to directly affect the very specific physiology of other organisms. There are certain species of acacia trees in Africa and in Central America that are covered with thorns, and some of the thorns are hollow, and the ants like them. And very similar to how us in our gut have friendly bacteria, and that's also a topic of what I'm going to talk a little bit about today. But just like we have friendly bacteria, these plants collect friendly ants, and the ants will recognize the newly formed shrubs, the babies, so to speak, and colonize them. And then the trees will produce a special nectar for the ants to eat, just like when we eat food for our good bacteria in our microbiome. That our healthy food that's healthy for us, feeds our good bacteria. The trees are producing a special nectar for the ants to eat, and then uh, uh, the ants will remove vegetation from around the base of the plant and remove other leaves and other plants that shade the tree, and they kill any vines that try to grow up the tree and attack the host. So the plants are doing these really super cool things. Um, uh, Bees are one of our great friends as humans. They pollinate our crops, so we are really symbiotically tied with bees. And bees are in great danger now, honeybees, and pollinating bees, especially in the States, and there are various hypotheses for why that's going on. But bee pollinators, especially honeybees, like to collect resinous substances from plants to make propolis. And propolis, the bees then use these plant chemicals to coat their hives and protect it from infection. And the resin is collected from all different kinds of trees and all different types of nectar. And propolis is generally about half tree resins, a little bit of pollen, lots of waxes, and then the bees will go specifically for terpenes. So, and we know medically, there's actually, I did a talk for the Australian Apitherapy Association a while back, and I got to learn a lot about this. But the propolis is actually very strongly antibacterial, antifungal, and it has specific properties that we think can give a lot of benefits in humans. And there are different types of bees, and so bees that are ground-dwelling bees gather specific combinations of propolis to line their hives. And many of the trees that this propolis is collected from will also exude salicylates. Salicylates are aspirin-like molecules, that bear pharmaceutical changed and formed a salicylic acid from willow. And that maybe might be a good time for me to segue in, because the willow bark has, as a medicinal for humans, has certain benefits that aspirin doesn't. A lot of folks will say, well, yeah, if they were trying to approve aspirin as a pharmaceutical today, it wouldn't pass because aspirin is so hard on the gastrointestinal tract. Interestingly, though, willow makes salicylates that are a little different than aspirin. Aspirin is fast acting. It's absorbed directly through the stomach, just like alcohol is, and immediately hits the circulation. The salicylates in willow bark do have to go to the liver first before they become active. But also in willow, the willow will also have polyphenol molecules that are phenomenally soothing for the digestive tract and anti-inflammatory for the stomach mucosa. And there are equivalent randomized controlled trials with willow bark showing therapeutic efficacy equal to or better than aspirin, but without the stomach side effects. So a lot of the times the plants are really the plant formulations can be very intelligent. And lots of animals will use plants intelligently, not just humans. So, for example, elephants will knock over a palm tree, stomp on the trunk, and then all the sap starts to come out. And it's a really one of the sweetest saps on the planet. It's a very sweet sap. And then the elephants stand and they gently rock the tree until until it ferments, and then they drink it and they get drunk. That is one thing that elephants do, but they will also utilize a whole host of medicinal plants for many conditions, including when the elephants give birth. Birds will collect fresh, strongly medicinal plants and weave them into their nests to prevent pest infestation, and they also can boost immune activity of the young. And the birds will also separate just the plants that they want from other plants that look similar, and they will gather different plants at different times of the year for different reasons. For example, starlings will regularly pick up and add plants that are high in very specific terpenes to their nests, so that the volatile oils and cannabis is a real good producer of terpenes, but the volatile oils consistently bathe them and their young, helping to prevent infections. And raptors, which are predatory birds, owls, eagles, hawks, because of the decaying meat, will regularly harvest strongly antimicrobial plants. And many birds do this. We know there's studies in India that wild pigs will dig up, it's actually called pigweed in India, and eat the roots, which have anti-worm, anti-parasitic compounds to control infestations. And in Mexico, they do the same thing, but they use a different plant that still contain the same chemicals as the ones in India do. Dogs, for example. So lots of animals. We're going to go through a few more. We'll do dogs. I already talked a little bit about elephants. I want to talk about bears too after I talk about dogs. Dogs will, if you have a dog, you'll see the dog eating grass. But dogs won't just necessarily eat any grass. They will sometimes separate out the particular type of grass that they want, including different for different conditions. One of dogs' favorite grasses is called quack grass, like the duck, quack like the duck. And it regulates the mucous membranes of the gastrointestinal system. It also possesses antimicrobial actions as well. And we talked a little bit about elephants. Monkeys. Primitive monkeys is a very primitive type of a monkey called a Siphica. And they usually don't eat plants that contain any tannins, but during the weeks prior to childbirth, they will seek out plants that control tannins, that have tannins in them. And tannins sometimes have what are known as styptic properties, which reduce the incidence of postpartum bleeding in childbirth. And certain African monkeys, chimps, gorillas, and spider monkeys will also seek out certain plants. Chimps will be very particular, and chimps are super close to us genetically, and they will select from a variety of plants depending on the nature of the parasite. For example, they will ingest the pith of the seed of one particular species to kill and stop the reproductive activity of a very specific parasite. But if they don't have that parasite, they don't go for that seed. And this particular seed contains a lot of sesquiterpene lactones and steroid glycosides. The glycosides actually suppress parasite movement, and also they slow down the worms from laying eggs, and that helps reduce their population density. When chimps are infested with an esophageal stomach parasite on a different parasite, they'll seek, for example, they seek out an entirely different plant. and they will eat the leaves of a certain plant. Text me or email me if you want the peer review on this. And they pick these leaves which contain it's called a thiorubune, and it is active against intestinal worms that commonly affect them. And what they do is they fold the leaves like, accordions, and they swallow them whole. And the unchewed leaves, because of the folding, and they're very specific, they kind of have little bristles on them, actually catch the worms. So they bend them, they bend the leaves, but they don't crush them. And so they're actually using both the chemical feature and a physical feature of the leaves. I find this extremely interesting. And the chimps are very particular about which part of the plant they choose, and they only use the certain pieces of that. Anyway, there's only one of you left in the room. Do you have a thought or a question, or I can keep talking? I'm not here to bore you with this if you find it not interesting. Okay, well, I will talk about bears then, and then I'll move on to a different topic. So bears, there's a plant called osha, and the Indians call it bear medicine. It's a ligusticum, which is a known medicinal. And in many different cultures, they use this. The Aztecs have used it for 100 years. And what the bears do is, in the early spring, they're waking up from their hibernation, and they come out and they dig up the osha root, which they eat. They'll also chew it and mix it with their saliva, and then they rub it all over their fur. So the male bears then will dig up extra roots, they'll clean them, and then they carry them to their mates who will have had babies. And then they wash them, and then they bring them to, and the osha root is very active against intestinal worms. So, do you have any thoughts or questions, V, if I'm even saying your name correctly there? No? Okay. Well, I think that I've talked a lot about probiotics. I've talked a lot about probiotics in my posts this month, and so I'll talk a little bit about probiotics. One of the few really truly sterile places on the planet where there's not any bacteria, one of the true naturally sterile places, I should say, as opposed to an autoclave, is the woman's womb. And the gestation period at the time directly prior to birth is the only time any human body is 100% free of bacteria. Immediately after birth, assuming it's a healthy birth, the baby is immediately normally placed upon the mom's chest near the nipple. And during that period, the first movements and the first bonding takes place. And the bacteria that are living on the mom's skin then begin to colonize her body. And it's perhaps no coincidence that, believe it or not, the largest amount of bacteria on the human body live near the nipple and the armpit. And so when the infant begins to nurse, the interior of the baby's intestinal tract is colonized with bacteria from the skin in and around the nipple and by the milk itself. And these bacteria are super important. The nursing introduces the bacteria, similar to bacteria found in yogurt and other fermented products, into the intestinal tract of the newborn. And the bacteria also create important vitamins, B vitamins, B1, B2, B3, B12, folic acid, which is necessary for the B12, and the folic acid are necessary for the development of the nervous system in the baby. Plus, they help digest the food, and the friendly bacteria secrete these natural antibiotic substances, one of which is called acidophilin. and various organic acids and other chemicals that help prevent non-friendly bacteria getting into and colonizing the bacteria tract. And these friendly bugs, the friendly bacteria, generate antibiotic substances, as I mentioned, that kill off other bacteria. For example, a type of a streptococcus bacteria, you've heard of strep, that normally live in the human throat over time, as the friendly bacteria are specifically active against some of these bad streptococcal bacteria. So that's the very beginning of the process. We know, and I've been posting on this all month, we know that the friendly bacteria create beneficial chemicals that talk both directly and indirectly to our immune system and to our nervous system. One of the ways they talk to the nervous system is through the vagus nerve, which is it's the 10th cranial nerve, is intimately interwoven into all of the major layers of the digestive tract except for the inner one. And the friendly bacteria produce feel-good neurotransmitters, one of which is serotonin. Serotonin is it's a tryptamine molecule, and over 80% of the serotonin in our body is created in the gut. A very similar molecule to the serotonin is known as melatonin, also produced in the gut. And so the friendly bacteria are creating B vitamins for us. They are helping us digest our food. They are providing us with vitamin K. They provide anti-inflammatory signaling to our immune system. They provide calming neurochemicals to our nervous system. And they prevent the growth of unfriendly bacteria. But a lot of the times in veterinary practice, the vets will always prescribe a probiotic for when they prescribe an antibiotic. But sometimes the gut bacteria can be compromised, and the unfriendly gut bacteria can get a foothold. And the unfriendly bacteria are like our own friendly bacteria. The unfriendlies are very smart. And when we eat I'm talking about the unfriendly bacteria now. When we eat food that the unfriendly bacteria like, even if it's bad for us, they'll secrete chemicals that make us feel good. And when they do that, we start to get cravings for certain types of food that make us feel good. I know I get a craving for pizza sometimes. But shortly thereafter, they stop doing that. Also, if we decide we want to be good and change our diet and eat a more healthy and live a more healthy lifestyle, and our bacteria in our gut are full of bad bacteria, when we start to eat good food, the bad bacteria will actually secrete chemicals that make us feel bad when we eat good food. So it's kind of like they're training us. So that's a brief summary of how the good and the bad bacteria work. On the cannabinoid side, which is kind of where my wheelhouse is to a large degree, CBD in the digestive tract helps with increasing populations of friendly bacteria, and it also helps decrease population of unfriendly bacteria. Also, THC does a similar thing. We know that, at least in animal studies, THC increases friendly bacteria, and I'd like to see more studies on that. But we also have a lot of studies about good food that's good for us. Green tea, polyphenols in green tea, the flavonoids in the proanthocyanidins in blueberry are polyphenols. The polyphenols in blueberry work in a similar way to the polyphenols in turmeric. They are working epigenetically, not necessarily just chemically. And when the polyphenols hit our friendly gut bacteria, they like that. They use that as food. It enhances their population. They're then able to synthesize B vitamins, vitamin K. They also create serotonin, which is 80% of the serotonin is created in the gut. And when we feed polyphenols to our friendly gut bacteria, the polyphenols then are able to secrete compounds that actually can motivate us to exercise. There's a real, actually pretty robust paper that I posted about a week or so on LinkedIn. If either of you want this, text me and I will send you the link. So these bugs are acting in a very intelligent and a symbiotic way. And when that serotonin is produced, as I said, it's a tryptamine in intimate orientation with the vagus nerve. So we get both indirect and direct stimulation or relaxation of our nervous system. We also have anti-inflammatory molecules that tone down hyperreactivity, and the gut barrier is healed all through this intelligent use of plants, which then affect not only our physiology directly through chemical means, but also indirectly through the friendly gut bacteria with which we encounter and help when we have a good diet. And interestingly, how long does it take? We have human studies that show that in as little as 2 days, you can, with a change in diet, you can get a turnaround in the gut signaling. So a relatively quick a change in the diet can relatively quickly turn it around. But what was interesting in this study is that the more robust the microbiome of the human was, the better the dietary features tended to make shifts. So if the gut was extremely compromised, it definitely was not as robust of a response as if the gut had a much more healthy bacteria population. So let me any thoughts or questions on that? So I've been talking for a while now, but I'd be happy to I could also shift and change topics. Any thoughts, comments, or questions? Okay, I'll pick another topic then. I think what I'd like to talk about is public health for a little bit, because I think that a lot of public health interventions can have profound effects on humans. Did I see your hand raised there, or was that a like? I think that was a hand raised there, Dr. Timothy. Let me see if I can bring you into the room. Yeah. Oh, there's a thumbs up, not a. Did you want to come into the room? You can raise your hand. If not, okay, I'll leave that as a thumbs up. Public health. Okay. So if you want to Google something that I think is cool, Google the fifth wave of public health. But public health is really interesting, especially when we think about it historically. One of my favorite features in public health is as a nurse by the name of Florence Nightingale. And Florence Nightingale had a very simple message that saved millions, if not more than millions, that would be in the billions of human lives. And that was very simply to teach doctors to wash their hands. Doctors washing their hands was her main message. And that was a public health measure. And that was known as the first wave of public health. The first wave of public health refers to how we dealt with the emergence of infectious diseases, typically in the early 20th century, many of them waterborne, cholera, but also viral, including Spanish flu, and these bacterial infections that caused widespread death and really kept human life expectancy low in the low 40s of numbers of years for both men and for women. So as we addressed these public health measures like Florence Nightingale, washing your hands, clean water, clean drinking water, adequate sewage elimination, we saw an immediate increase in life expectancy dramatically. And then we solved that problem. We walked into another problem, as so often happens in the universe when we solve one problem. And so we solved the problem with the first wave of public health with infectious diseases, but then came longer lives, and then came chronic diseases. So the second wave of public health is characterized by the rise of chronic diseases and heart disease, cancer, diabetes, which were in existence earlier, but not as common. And this is more middle of the 20th century. We started handling those to a degree better, but they still plague us today. Then what is known as the third wave of public health were the emergence of weird, strange viruses that we had not really encountered before, many of which had come from animals as deforestation of humanity began to creep into the wild. HIV, which came from, if I'm not mistaken, from a monkey or a simian virus. SARS is another one, H1N1. This third wave of public health are these weird and strange diseases that we had not seen immediately after the first wave, because we were just really dealing with heart disease, cancer, and diabetes. But as humans expanded, we had the third wave. And then the fourth wave is characterized by the increasing wave of antibiotic resistant bacteria. So we solved a lot of the problems with antibiotics, but the bugs got smart, as they often do. And they started, the bacteria is what I mean by the bugs, and the antibiotic resistance started growing. And believe it or not, we have not had a new type of antibiotic, a new class of antibiotic, in about 30 years. I believe it was erythromycin was, I believe, the most recent class. But anyway, so we're losing that battle in the fourth wave. And I think that's where plants can really help us, because plants, there's a really cool Vietnamese study on malaria, which is not a bacteria, but it illustrates the example. Malaria, the plant, which is in the chrysanthemum family, makes a molecule that is a berberine alkaloid. Golden seal has this same alkaloid, and where I live in Washington, we have Oregon grapefruit, which also makes this berberine compound. And you can take this berberine compound by itself and administer it to humans, or you can administer it and it kills the malarial parasite. But if you're just using that chemical all by itself, the malaria very quickly develop resistance to it and it becomes ineffective. However, if you use the entire plant, that chrysanthemum plant has flavonoids in it, which in and of themselves have absolutely no effect. If you just isolated that molecule, have absolutely no effect on the malarial parasite. However, if you give it as a whole plant product, the berberine alkaloid combines with the flavonoid, and the malaria does not develop resistance. So I think these plants have a lot to teach us. We know from studies now, hard science, peer-reviewed studies, that CBD possesses remarkable antibacterial properties through a new mechanism that we do not know how, what, or why as of yet, but it's been 30 years since we have had a new antibiotic class, and it's looking like CBD might be helpful. But if we lose the lesson of combinatory therapy and synergistic therapy, we might have to relearn the lesson that we learned with berberine, that these molecules alone might be effective, but a lot of the time when combined, have superior effects to the single molecule themselves. So, fifth wave of public health. We're at the fifth wave now. Threats to public health that are not addressed by existing frameworks of culture. In the US, we have an epidemic of loneliness. Our old people are lonely. It's terrible. And we feel separate. But also the fifth case is involved in climate change, and climate change is causing all types of problems, including public health. The air quality in certain cities is horrific, and in certain developing countries is just really bad. Also, we have the emergence of new infectious diseases and the continued rising burden of chronic diseases, but also bioterrorism and intentional harm. So the fifth wave of public health has to do with our sickness as a culture. It's not just the biologic features as well. Anyway, I've done about a 45-minute monologue here. I really appreciate you all for hanging in there with me. Does anyone have any questions? I'd be happy to take a question before I wrap things up here. I think the next time I do this, I'm going to do video, because I'm just getting a sense that the audio response is not as